Hello, Joe here with another upgrade to my 1977 Catalina 30. This time I rebuilt my 37-year-old wet rudder. Instead of using a typical fiberglass and foam, I used HDPE plastic and stainless steel, so I never have to worry about water in the rudder again. I hope you enjoy the video.
The first problem I encountered was that my 1977 Catalina rudder was about 25% larger than a 1980s Catalina rudder. When I contacted Catalina, they said, "Oh yeah, you have the older rudder. You'd be much better off with the newer rudder. It has better backing capabilities." So I took a design off a newer about a 1985 Catalina 30, and basically just took the profile. I did add more balance to the front of the rudder. There's very small amount of balance on that rudder, and I wanted to add a little bit more balance. So what you see here is a Schedule 40 stainless steel pipe with the shape in 1/8 inch stainless steel that I was looking for, and then I added these 3 little ribs to stiffen it. That was all professionally welded. I did not weld that myself. I brought that to a welding shop. Since the stainless steel was flat and I needed to add some hydrodynamic capability to it, I decided to face it with Evolve lumber. Now this is a PVC-free lumber. It's completely HDPE plastic, and it's actually manufactured close to where I am, about 60 miles away, so I can just go to the manufacturing plant and pick it up. Certainly you would be able to order it, or you might be able to find it at a local lumber yard. For those of you that are really interested in some of the specifications on that HDPE lumber, here's a density table. So you can see that HDPE is not as dense as water, which means it technically floats, even though 0.95 to 0.96 is not much. It will be heavier than your former rudder, but in the water it won't weigh anything. The plastic won't add any weight. So I was happy to see that. The other thing that you'll want to know is that the water absorption rate for HDPE is 0.01%. I mean, that's why we use HDPE plastic for plastic jugs, so you don't have to worry about any water absorption. The lumber that I bought was, the actual lumber size was 1.5 inch by 5.5 inches. In this picture you can see here's a 12-foot length. Now 3 12-foot lengths, which cost about $50 a piece, was what I needed to go ahead and start building the facing on the rudder. I started by cutting the sections that I needed that were the length of the area of the rudder that I was going to be facing off. I went out and I found the NACA 012 cross section, and then I created this little pattern which would allow me to score the sides of the plastic and put the appropriate cuts onto the plastic. I cut relief cuts into the center for the center pipe, and then I went ahead and cut around the relief cuts, and that allowed me to cut out the pipe section. I then sanded that so that it would fit nice and tight. In this picture you can see the end result of just cutting the pipe section, the rudder post section, and then I fit it on and continued to use the sander until I got a nice snug fit. The next thing I did is I took my pattern and I scored the NACA airfoil shape. I needed to get more surface area on the bandsaw, so I made this little block of wood that I screwed to the inside so that I would have more surface area on the bandsaw to make my cuts. And what I ended up with, you see here, were all the different facings. After having all the shapes cut out, I placed them on the rudder to find out where I would be drilling my holes. Because of the ribs, I had to drill holes in different locations. So I got the plastic placed on, tightened down. I drilled the holes. I then countersunk those holes and used ⅛/28 threaded rod with all stainless, with stainless nuts and fender washers. Once all the pieces were on, both the port and the starboard side facings, I tightened it down with Loctite, and then I used some plugs some plastic plugs to cover up the holes, and sanded the entire rudder with a belt sander. And of course, here is a picture of the rudder installed on the boat. I have had a chance to sail the boat and motor the boat with the new rudder. It really feels different. I wish there was some scientific way I could have tested the previous rudder versus this rudder, but I did make it a little deeper, and it does have a better shape, and I'm real happy with this rudder install. I just have to give some special thanks to my father, Tony, who without his help I would have not been able to build this rudder. He's an engineer. He dealt with all the math. He dealt with getting the correct shape and the patterns. He dealt with the machine shop, getting everything cut and welded properly. Without him, I would not have been able to do the build.